So in class, we learned that we can identify functions as even, odd, or neither in two ways, both algebraically or graphically. And we looked at it in a graphical form where we learned that even functions are when your graph have a reflexive symmetry over y-axis. And we looked at it through a particular example where y equals x squared, which is a parabola. We chose an input of an x value positive 2. And when we brought it up, we saw that it has a y value of 4. When we reflect that graph over the y-axis to the other side, now our x value is negative, but bring it up, it still has the same positive 4 as the y value. So we wrote it as f of 2 is equal to f of negative 2, because whether the input is 2 or negative 2, you still get the same output. And as a generalization for all values of x, we came up with one algebraic definition saying f of x equals f of negative x. And we did the same thing for odd function, and we looked at x cubed function. This time, when your x value was a positive 2, bring it up, 2 cubed is positive 8, so we got a y value of 8. And then when we were to reflect it over the y-axis, and then reflect it again, this time for that negative x value, now we have an output that is of the same value of 8, still 8, but the opposite. It's the opposite value. Therefore, we could set f of 2 equals, which was 8, it's going to be negative of f of negative 2. But if you move the negative side to the other side, we have this form. And as a generalization, the math algebraic definition of odd function we found was this. And going from this curve right here to this curve, that is a rotational symmetry about the origin, specifically 180 degrees. So this curve right here, if you rotate it 90 degrees, it will look like this. That's 90 degrees. But if you go another 90 degrees, which is total of 180, now you have the curve coming down. So 90 plus 90, that gave us 180 degrees of rotation. Okay, so then putting it together, we have both the even and odd functions definition in graphical terms, as well as the algebraic terms. And of course, we have functions that are neither of those two. So then looking at some examples. Let's determine if any of these functions are even, odd, or neither. You've seen this in class, so this could be a repeated practice. So first, we have f of x equals x squared. We know that it's even, but let's confirm. So I'm going to erase it. We know that a function is even if f of negative x is equal to f of x. And we know that a function is odd if f of negative x is equal to negative of f of x. So let's first see if it's even. Is this function even? Is f of negative x equal to f of x? And following this order will always make the process easier. So we know what f of x is. We got to find f of negative x. And we do that by replacing wherever the x's are with just its opposite, which is negative x. So negative x squared, that's negative x times negative x, which is positive x squared. So then, answering that first question, is f of negative x, which is x squared, is that equal to the original f of x? In this case, the answer is yes. Since f of negative x is equal to f of x, this is an even function. And then let's look at a different one. This time we have g of x equals to x cubed. So first, let's check it's even. Is g of negative x going to equal to g of x? So just like previously, we got to first check what g of negative x is going to be. Replace the x with negative x, parenthesis. This time, negative x cubed. Negative x times negative x times negative x gives us negative x cubed. So, is g of negative x, which is this one, equal to g of x? In this case, it's a no. They're not the same. So it's not even, which means you got to go further and check if it's odd. An odd definition where g of negative x is equal to negative g of x. We already know what g of negative x is. We found that already. So now we're going to have to find negative of g of x. And we find that by multiplying that entire g of x function, which is x cubed, multiply that by a negative. And that's going to equal to negative x cubed. So then answering the second question, is g of negative x, which is this one, is that equal to negative g of x, which is what we found down here? And the answer is going to be yes, they are the same. G of negative x is equal to negative g of x. Therefore, this is an odd function. Now let's take a look at this one. This is actually one I warned you about in class, where you have the entire quantity with parentheses squared. In this case, before you check whether it's even or odd function, you want to rewrite it by expanding. Okay, if you have parentheses with squared or exponents on top, you want to rewrite it. So this is going to become h of x equals x plus 5 times x plus 5, which if you multiply them all out, it's going to equal to x squared plus 10x plus 25. So now let's check if this function is even first. So our first question we're going to answer is h of negative x equals to h of x? So let's find the h of negative x, which is going to be replacing every x with negative x. So negative x squared plus 10 times negative x plus 25, which if we simplify would be x squared minus 10x plus 25. So then ask yourself, is h of negative x, which is this, equal to the h of x? Compare them. And in this case, they're not equal to each other. They are different. So it's a no, that's not even. So then the next part, we're going to have to check if it's odd. So let's see, is now h of negative x equals to negative of h of x. And again, since we have done h of negative x up here, now we're going to have to find the negative h of x. And that's going to be the entire quantity of h of x, this entire thing, being multiplied by negative 1. So negative 1 outside, and put parenthesis around the entire x squared plus 10x plus 25, which simplifies to be negative x squared minus 10x minus 25. So is negative h of x, which is our line above right here, h of negative x, is that equal to negative h of x? Are these two, pink, highlighted, equal to each other? In this case, this answer is going to be no. They're not equal to each other. So it's not even, not odd, therefore the answer is neither. Oops. neither would be the answer for this one. Okay, so if you think you understand it, you may pause it and practice on your own. But I'm going to do one more. I'm going to do the one over here, k of x. So first, again, let's check to see if it's even. Following the procedure, is k of negative x equal to k of x? And we need to find the k of negative x and compare that to the original equation. So negative 3 times negative x to the fourth plus negative x to the power of 3. In this case, any negative value raised to an even exponent, it's always going to be positive. So this is negative 3 times positive x to the fourth plus, now any negative value raised to an odd exponent will always be negative, right? Because it's now negative times negative and then another negative. So negative x cubed will actually equal to negative x cubed. So we can put minus x cubed. So then ask yourself, is k of negative x that we found equal to the original k of x? Are they equal to each other? In this case, this is a no. They're not equal to each other. So we're going to have to continue. Let's check if it's odd. Is k of negative x equal to negative of k of x? So again, hopefully now you're getting into the rhythm of this. Now it's negative k of x that we have to find, which again is basically you're multiplying the entire k of x right here by negative. 6 to the fourth plus x cubed. So if we distribute the negative, this is going to give you positive 3x to the fourth minus x to the power of 3. So then ask yourself, is k of negative x, which is what you found earlier, so you're just comparing the one right before to what you just found right now, negative k of x, are they equal to each other? And again, answer is going to be no. Therefore, this one is also a neither.